Hello, my name is Jonathan Varner, and I'm a product manager with Autoform. I'd like to talk today about tooling geometry, specifically how this fits into your development and your design process. When we think about the big picture, what are we trying to do? We're trying to create a really accurate process, or we're trying to manufacture a set of tools that produce the desired outcome. So our process means nothing unless it can do that. When we think about the geometry workflow that leads up to this, we have to be aware of some options that we have available to us to do this in a more efficient manner. The Autoform accuracy footprint is one way that we can visualize the inputs that are needed to make this ultimately accurate process. There are many different categories. And of course, I'm talking about tooling geometry. Tooling geometry itself is one major component. In fact, I think of it more of in the terms of material, process parameters, and geometry are very large overarching categories that fit into the accuracy footprint. So that's one large portion, the geometry, the tooling geometry of our accuracy plan. If we now take the geometry workflow and we take a closer look at a subtask of geometry, we first get a part geometry and we have to create a concept. It's just an image. It's a fast way to prove out that this is the way to process the part. We can go through many different iterations of either the part geometry or the process itself and the tooling geometry to arrive and make that final decision. Going through the next stages, we start to become more and more limited only because we have an elevated level of accuracy of the surfaces and more complex topics such as compensation. This overall process really leads us to our final goal, but let's go back and take a little closer look at the concept stage. How do I do this? How can I more efficiently create my geometry and still feel confident about the level of the accuracy of the surfaces as well as my decision? If I were to say this in a different way, let's first consider what we're used to, our experience and our standards. We follow these and we build something that's a good set of tooling surfaces. But would we be so confident that we could say that we don't need to run a simulation? We don't need to do any additional investigation? I don't think the answer to that would be yes. We still want some sort of additional information, a higher level. The simulation results are really what bring us to a culmination of our standards and our experience being validated. So we really have to leverage our experience, our colleagues' experience, standards, as well as the simulation results. And we can't get simulation results unless we have tooling surfaces. So the simple fact that we need to develop concept geometry, tooling surfaces, fast enough that we can answer the bigger picture, bigger decisions about our process intent. There's simply no replacement for this. And the faster we can prove our concept, we can move to the next stage and begin to build high quality CAD surfaces, knowing that we don't have to revisit and do a bunch of extra rework to those surfaces that were created. The benefits are clear. By developing our tooling surfaces so fast and efficient using Die Designer in this early concept stage allows us to make big key decisions faster. It allows us to communicate better with our colleagues and our suppliers. And this leads to a higher level of accuracy and analysis earlier in the development cycle. This has bigger benefits than just surface creation time. This allows everything to be moved forward in the process and ultimately ends up in a higher level output of the accuracy and the prediction of the process. I invite you to contact your local Autoform office or myself about the opportunities that await for you using Die Designer.